Have you ever wondered how vast and interconnected the universe truly is? Galaxy clusters and superclusters are among the largest structures in existence, holding secrets that redefine our understanding of space. Did you know some of these clusters are bound by mysterious forces like dark matter, or that their sheer size stretches the limits of imagination? Join us as we explore 7 surprising facts about galaxy clusters and superclusters, unraveling the cosmic threads that weave our universe together. The immense size of galaxy clusters. Imagine a structure so vast, it stretches across millions of light-years, and holds thousands of galaxies within it. That's the mind-blowing reality of galaxy clusters. These colossal gatherings of stars, planets, and cosmic dust are like bustling cities in the universe, each teeming with activity on a scale that's hard to wrap your head around. At the center of many clusters, you'll often find a massive elliptical galaxy that acts like a gravitational anchor, pulling in smaller galaxies and holding everything together. These central giants are surrounded by spirals, lenticulars, and irregular galaxies, each moving in a gravitational dance that's been going on for billions of years. But here's the wild part: it's not just the galaxies themselves. Between them lies a superheated plasma called the intracluster medium, glowing in X-rays and holding clues about the cluster's history and formation. What's even more incredible is that these clusters don't just sit in isolation. They're part of an even grander structure called the cosmic web, connected by filaments of dark matter and gas that stretch across the observable universe. Galaxy clusters form the nodes in this vast network, showing us how matter is distributed on the largest scales. And remember, we're not just talking about a few stars or galaxies here. We're talking trillions of stars, planets, black holes, and other celestial wonders, all crammed into these epic clusters. Studying galaxy clusters doesn't just give us a snapshot of the universe's grandeur, it reveals its secrets. From the mysterious role of dark matter to the processes that shape galaxies themselves, these clusters are like a treasure chest for astronomers. They're a reminder of just how vast, interconnected, and awe-inspiring the cosmos truly is. Dark matter holds them together. Think about this. Without an invisible, mysterious force, galaxy clusters would completely fall apart. That force? Dark matter. It's the glue of the universe, holding these gigantic clusters together even when they should be flying apart. But here's the kicker: no one's ever seen it directly. Scientists figured out dark matter was there because the math just didn't add up. When they measured the visible mass of galaxies, stars, planets, gas clouds, it wasn't nearly enough to account for the gravitational pull holding clusters together. The galaxies within these clusters are moving at such insane speeds that, without something extra adding mass, they'd be flung into space like confetti at a party. That's where dark matter steps in, making up about 85% of the total mass in a cluster. What exactly is it? That's still a cosmic mystery. It doesn't emit light, absorb it, or interact with regular matter in any way we can see, touch, or measure, at least not yet. We know it's there because of its gravitational effects. It bends light from distant objects in a phenomenon called gravitational lensing, acting like a cosmic magnifying glass. Without dark matter, we wouldn't see those telltale light distortions around clusters, which have become key evidence of its existence. Dark matter isn't just a supporting actor in the galaxy cluster drama, it's the star of the show. Without it, the universe as we know it wouldn't exist. Galaxies wouldn't have formed, clusters wouldn't hold together, and we wouldn't be here to marvel at the cosmos. It's the invisible scaffolding of the universe, reminding us that some of the most important pieces of reality are the ones we can't see. How's that for a cosmic plot twist? Superclusters are cosmic giants. If you think galaxy clusters are impressive, wait until you hear about superclusters. These are the true titans of the cosmos, sprawling structures made up of multiple galaxy clusters bound together by gravity. Superclusters are so vast that they stretch across hundreds of millions of light-years, forming intricate webs that shape the very structure of the universe. Picture a network of filaments and nodes connecting glowing clusters of galaxies, like a cosmic spiderweb on an unimaginable scale. The size of superclusters is so enormous that it's difficult to wrap your head around it. Take the Laniakea supercluster, for example. This is the colossal cosmic neighborhood that our Milky Way calls home. It spans over 500 million light-years and contains around 100,000 galaxies, each one packed with billions of stars. To travel across Laniakea at the speed of light, it would take you 5 million centuries. Yes, centuries. And that's just one supercluster in a universe teeming with them. What makes superclusters even more fascinating is how they're arranged in the cosmic web. Instead of being randomly scattered, they form the universe's large-scale structure. Superclusters are connected by filaments of dark matter, with vast voids of empty space in between. Imagine looking at a three-dimensional map of the cosmos, where the bright points represent galaxies and clusters, and the threads connecting them reveal the invisible scaffolding of dark matter. This structure tells the story of how the universe evolved, from a hot, dense state to the sprawling expanse we see today. Despite their immense size and influence, superclusters aren't permanent. Over billions of years, their gravitational pull will eventually overcome their cosmic bonds, and the galaxies within them will drift apart as the universe continues to expand. It's a humbling reminder of how even the mightiest structures in the cosmos are subject to the relentless forces of time and space. Superclusters are a testament to the universe's complexity, showing us how small we really are while inspiring awe for the grandeur of the cosmos. The role of gravitational lensing. Gravity doesn't just hold galaxies and stars in place, it bends light itself, creating one of the most fascinating phenomena in the cosmos: gravitational lensing. This happens when the immense gravitational pull of a massive object like a galaxy cluster warps the space around it, bending light from more distant objects. Imagine looking through a cosmic magnifying glass that stretches and distorts the view of what lies behind it. It's both a scientific marvel and a natural work of art. Gravitational lensing isn't just a curiosity, it's an invaluable tool for astronomers. By analyzing these cosmic distortions, scientists can uncover details about the universe that would otherwise remain hidden. For example, when light from a distant galaxy passes through a galaxy cluster acting as a lens, it gets magnified, allowing astronomers to observe faint galaxies billions of light-years away. These magnifications have given us glimpses of the early universe, helping us study how galaxies formed and evolved. But that's not all. Gravitational lensing also provides a window into the mysterious world of dark matter. Since dark matter doesn't emit, absorb, or reflect light, it's invisible to our telescopes. However, its immense gravitational influence affects how light bends around galaxy clusters. By studying these lensing effects, scientists can map the distribution of dark matter, uncovering its presence and understanding how it contributes to the structure of the universe. Without gravitational lensing, our knowledge of dark matter would be far more limited. Perhaps the most stunning examples of gravitational lensing are the visual phenomena it creates. Einstein rings, arcs, and multiple images of the same distant object are all results of light taking different paths around a massive lensing object. These cosmic spectacles are a testament to the power of gravity and the vastness of the universe. Gravitational lensing turns the sky into a canvas, revealing both the beauty and the secrets of the cosmos in ways we are only beginning to comprehend. The extreme temperatures of the intracluster medium. The space between galaxies in a cluster isn't empty, it's filled with a searing hot plasma called the intracluster medium, or ICM. This vast expanse of gas reaches mind-boggling temperatures of tens of millions of degrees. Imagine an environment so extreme that atoms are stripped of their electrons, leaving behind a sea of charged particles. The intracluster medium is not just a space filler, it's a key component of galaxy clusters, accounting for more mass than the galaxies themselves. This scorching plasma emits intense X-rays, making galaxy clusters some of the brightest X-ray sources in the universe. By observing these X-rays, astronomers can study the composition, temperature, and density of the ICM, revealing the intricate details of how galaxy clusters form and evolve. The X-ray emissions also allow us to measure the mass of the clusters, providing crucial insights into the influence of dark matter and the role it plays in binding these cosmic giants together. The extreme temperatures of the intracluster medium are powered by the gravitational energy of the cluster itself. When smaller clusters or galaxies collide and merge into a larger cluster, the resulting shockwaves heat the ICM to these incredible temperatures. These cosmic collisions are on a scale that's hard to fathom, but they're essential for shaping the structure of the universe as we see it today. The heated plasma also carries a wealth of information about the violent history of galaxy clusters and their ongoing interactions. What's truly fascinating is how the ICM interacts with the galaxies it surrounds. The hot plasma exerts pressure on the galaxies, stripping away their gas and stalling star formation in a process known as ram pressure stripping. This dynamic interplay between galaxies and the intracluster medium shows how interconnected the universe is. The ICM isn't just a byproduct of galaxy clusters, it's a vital player in the cosmic ecosystem, influencing everything from star formation to the growth of the largest structures in the universe. The Great Attractor, a cosmic mystery. Deep within the vast cosmic web, an invisible force draws galaxies toward a single point in space, a phenomenon scientists call the Great Attractor. This mysterious region, located about 150 to 250 million light-years away from us in the direction of the constellation Centaurus, exerts a gravitational pull so massive that it's reshaping the movement of entire galaxy clusters. It's not just a small anomaly, this enigmatic force impacts the trajectory of our own Milky Way and countless neighboring galaxies within the Laniakea supercluster. The Great Attractor isn't fully visible to us because it lies in what astronomers call the zone of avoidance, a region of the sky obscured by the dense plane of our galaxy, filled with stars, gas, and dust. Even so, researchers have used radio waves and X-rays, which can penetrate the Milky Way's dense shroud, to begin piecing together the secrets of this gravitational behemoth. What they've found so far is awe-inspiring. The Great Attractor appears to be a region of immense mass, likely populated by enormous galaxy clusters and a significant amount of dark matter. What makes this force even more intriguing is its potential role in the larger cosmic structure. Some scientists theorize that the Great Attractor might be part of an even larger feature called the Shapley supercluster, the most massive concentration of galaxies in our observable universe. If this theory holds true, the Great Attractor isn't just a local cosmic influence but a pivotal piece in the grand design of the universe. Observing the flow of galaxies around this region reveals the gravitational dominance it commands, stretching its influence far beyond what we might initially imagine. Despite decades of study, the true nature of the Great Attractor remains one of the universe's most tantalizing mysteries. Is it a massive cluster of galaxies, a dense web of dark matter, or perhaps something entirely unforeseen? As technology advances, astronomers continue to peel back the layers of this cosmic enigma, promising us a deeper understanding of the forces that shape the very fabric of our universe. Until then, the Great Attractor remains a captivating reminder of how much we have yet to uncover about the vast interconnected cosmos. Superclusters are still expanding. Superclusters, the colossal arrangements of galaxy clusters stretching across hundreds of millions of light-years, are far from static. These cosmic giants are still expanding, driven by the relentless force of the universe's expansion itself. This vast movement originates from the aftermath of the Big Bang, and is powered by an elusive and mysterious entity known as dark energy. Superclusters might seem like immovable structures, but in reality, they are dynamic participants in the ever-evolving story of the cosmos. One of the most fascinating aspects of their expansion is how it alters the relationship between galaxies and clusters within them. Gravity works to hold galaxies together within their clusters, forming dense, interlinked webs, while dark energy exerts an opposing force, pulling these clusters farther apart on a grander scale. This tug-of-war creates a stunning visual when mapped out, intricate, thread-like filaments of galaxies stretching across an otherwise empty void. These structures aren't just expanding, they're evolving, with gravity slowly tightening the bonds within clusters while the overall web continues to stretch outward. The expansion of superclusters also shapes the way galaxies move and interact with each other. While some galaxies might collide and merge due to local gravitational pulls, others are being swept apart by dark energy's influence. For example, even as the Milky Way and Andromeda galaxies are on a collision course, they are being carried along with the local group toward larger structures like the Virgo supercluster, and beyond that, the Laniakea supercluster. However, as time goes on, galaxies outside of our local gravitational influences will recede farther and farther into the vastness of space, eventually disappearing from view. This ongoing expansion presents a paradoxical beauty. The universe is simultaneously pulling galaxies together in some regions while pushing everything apart on a larger scale. It's a stark reminder of the duality at play in the cosmos, a world of unity and separation, gravity and dark energy, clustering and expansion. These massive superclusters serve as both the architects of cosmic structures and symbols of the universe's ceaseless transformation. By observing this endless expansion, scientists gain deeper insights into the fundamental forces shaping the universe and glimpse its ultimate fate. Galaxy clusters and superclusters are incredible cosmic phenomena that continue to captivate and challenge our understanding of the universe. From the fiery temperatures of the intra-cluster medium to the enigmatic pull of the Great Attractor, each discovery reveals more about the forces shaping our cosmos. If you found this exploration as thrilling as we did, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.